AWS Global Accelerator is a new service, and it's one that's going to come up in the SAA C02 exam. And I saw it quite a lot in my beta exam. I think 2 or 3 questions either had it as an answer or had it as a distractor, so an incorrect answer. So you definitely need to know what it is. And it's also quite an exciting service as well. So it's one that you might find really useful in certain scenarios in your work as a solutions architect. So AWS Global Accelerator is a service that improves the availability and performance of your applications with local or global users. So it provides static IP addresses that act as a fixed entry point to your applications in single or multiple AWS regions, such as ALBs, NLBs, and EC2 instances. So that means you get static IP addresses, which are fixed IP addresses that you can use to direct users to applications in multiple regions. And we'll see what this means in the diagram shortly as well. So I've got a diagram and we're also going to do a hands-on. Global Accelerator also uses the AWS Global Network, so that optimizes the path for users to applications. And it does so for TCP and UDP traffic. So what this means is that Global Accelerator is actually going to direct traffic over the AWS network. So when you go and hit an endpoint for Global Accelerator, you're actually hitting the CloudFront network, which means that there's the CloudFront edge locations around the world. You're being directed to an edge location. And then from there, your traffic, no matter what region it's going to, is going to go through the global network. So that means you're not using the internet. So you're not subject to the potential latency issues that can occur on the internet, especially over long distances when you're failing your application between regions. So let's have a look at what this looks like. So in this diagram, we have users, and these users are in the US. And what they need to do is they need to connect to an application that's running on the domain name dctlabs.com. So what they're going to do firstly is they punch that into their browser and they try to connect to this web application. And what they need to do first is resolve the IP address for dctlabs.com. And we're going to use Route 53 for that. So they send a request to Route 53. Route 53 then responds with 2 IP addresses. Now these IP addresses are static anycast IP addresses, and that means there can be multiple hosts behind these IP addresses, but all you're ever going to see for your application is these 2 IP addresses. So let's say that you have users around the world and you have customers potentially, and they need to whitelist some IP addresses in order to be able to connect to the application that you're providing for them. These are the 2 addresses they're going to need to use, nothing else. It doesn't matter where they are in the world, so that's really useful. It also means when we have a failover between different regions, so our application endpoints in different regions, these IP addresses don't need to be changed in the client's browser. So they'll be cached in the client's computer on their browser, and it doesn't matter because normally you have to worry about how long it's going to take for those cached entries to expire before the browser or the computer needs to go and do another lookup to find out some new IP addresses. In this case, the IPs don't change, so that's not an issue. So what happens next is these IP addresses are associated with edge locations, so the users get directed to a CloudFront edge location, and that then connects them to the AWS Global Accelerator, which forwards them to dctlabs.com, in this case in US East 1. So the user is now connected to the application running in US East 1. So what happens if this application fails? So let's say the application has failed and the user now needs to connect to another version of your application, another instance of your application running somewhere else in the world. So what happens is AWS Global Accelerator will direct the users straight to dctlabs.com in this case EU Central 1. Now it's the same IP addresses. The IP addresses haven't changed, the browser cache doesn't need to change, and the traffic is going over the global network. So even though the users are in the US and the application is now in Europe, the traffic is going via the AWS global network. That means it's very fast and very low latency. Let's head over to the console now, and we're going to build out a architecture very similar to this one. And what we're going to have is we're going to have an application endpoint running in 2 locations, probably both in the US, but you'll see how this works. What we're going to do now is go over to the AWS Management Console, and we're going to build a solution very similar to this. I'll probably have instances both running in the US, but in different regions within the US. And otherwise, this is going to be very much the same. Of course, it will assign some different IP addresses as well. They're automatically assigned when you create the global accelerator. So let's head over to the console and build this out. I'm in the AWS Management Console. Let's go to Services, and we go down to Networking and Content Delivery and choose Global Accelerator. So before we start configuring Global Accelerator, what we need to do is launch our instances, so our application endpoints. The first one I'm going to do is in US West 1, North California. And what I'm going to do is launch an instance. It's going to be a Linux 2 AMI. It will be a T2 micro. And I'm going to put in this user data. So what I'm going to do here is, all I'm going to do is just update this to US West 1. So this instance is in US West 1, and that's basically what's going to be on the index.html when we connect to this web server. So it will let us know which endpoint we're connecting to. And let's just go through to security groups. I need to give it web access, which in this case, all I need is port 80. Let's launch. And now we're going to do the same with US West 2. So Linux 2 AMI, T2 micro, and then let's put in US West 2 into this user data. And again, just make sure you've got a inbound rule for port 80 in your security group. And that instance is now going to launch. So we can go to our accelerator. Just before I do that, I want to search for AWS Global Accelerator pricing. And let's just have a look at the pricing for Global Accelerator. Now, I don't know if there's any credits for the free tier, but what you will see here, there's a fixed fee for every hour you have a accelerator running. And that's the fee. So it's 0.025 per hour. The other component of the pricing is the per gigabyte pricing, so how much data you put through Accelerator. So we're really not going to generate much traffic at all. It's going to be kilobytes, if anything. So I wouldn't worry too much about this pricing, but you will pay a small fee for each hour that you have your accelerator running. So just remember to disable your accelerator at the end of the lab. So let's go and create our accelerator. Now I'm just going to call this my accelerator. Choose next. We create a listener. It's going to be port 80 for HTTP. It's going to be TCP. You can choose to set up client affinity, but we don't need that for now. And we now need to set up our regions. So the first one was US West 1. And we're also going to set up US West 2. Now the traffic dial controls how much traffic you send to your different regions. So it's kind of like a weighting, and you say, I want to send this amount to this region and this amount to this region. Now we're not going to change that. So what that will mean is you would be directed to the region that's healthy, that's closest to you. Let's choose next. And we can now go and add our endpoint. And you can choose from an ALB, an NLB, an EC2 instance, or an elastic IP. So let's choose EC2 and let's find our endpoint. So we can see that the instance we just created is actually present here. And as you can see, you have a weight here. And the dial that we looked at in the previous screen, that controlled how the traffic is sent to the region. But then within a region, you can have a weight assigned to each instance that you have. Now we've only got one instance in each group, so that doesn't matter. So we'll just leave it as default. I'm going to set up my EC2 instance endpoint in US West 2. And there's my EC2 instance. And that's all we need to do. So we can just create the accelerator. Now just close that out. I did delete an accelerator that I set up a few minutes ago. And we can now see that our latest accelerator has been created and it's in a in progress status. But straight away we can see that we have our static IP addresses here. So these IP addresses, either one of these will direct you to whichever endpoint is either, well, that has to be healthy, but is closest to you, unless you have those dials set in some kind of way to deliberately control traffic one way or the other. Now, while this is being set up, what I want to do is just go to Route 53. I'll open this in a new tab. And I'm going to set up those records in Route 53. So I'm just going to copy these IP addresses. We'll go to Route 53, go to Hosted Zones, and choose dctlabs.com, and I'm going to create a record set. Now, if you haven't registered a domain name, just use the IP addresses. You don't have to do this, but I just want to set it up anyway to make this look like a more complete solution. So I'm going to leave this blank up here because I just want the name to be dctlabs.com. It's going to be an A type of address. That means resolving a domain name to an IP address. And we're going to put these IP addresses on separate lines. Now we're just going to leave it as simple routing policy. That means it will use round robin, so it will sort of basically give either of these as a response, and it kind of just cycles through. Let's choose create. And now we have our record set. So that took a few minutes, and the accelerator is now showing as being deployed. And if we just click on Accelerator here, we can see that we have our endpoints in US West 1 and US West 2, and they're all healthy, so that's great. So we've got our Route 53 set up with the IP addresses of the global accelerator. So what we should be able to do now is let's just go to http://dctlabs.com, and we get directed to the instance in US West 1. So that's great. We know that we've set up Route 53 properly. We've set up our global accelerator. Our global accelerator has an endpoint which is healthy, and we've connected to that endpoint. So going back to our diagram, this is basically where we're at. We have a couple of IP addresses. We've resolved dctlabs.com to those IP addresses, and we've connected to an endpoint. In our case, it's US West 1. Now, what we want to do now is simulate the failure of one of those instances so that we then get directed to our other instance or our other application endpoint, just like in the diagram here. So let's go back, and we're going to terminate one of the EC2 instances so that we then get a failover. So I'm in US West 1, and what I'm going to do is, this is my instance. I'm just going to terminate my instance and choose terminate. And so that instance is no longer available. If we come back and refresh the screen, we can see it's kind of timing out because there is a period of time. By default, it's going to be 30 seconds for the health checks. So the global accelerator needs to identify that the endpoint is unhealthy before it starts routing traffic to the other endpoint. So if we head back in and have a look at our accelerator, we can see that our endpoints are still all healthy. So I'm just refreshing to make sure that that's current. Now, once we see that at least one endpoint is unhealthy, in this case it will only be one endpoint, then at that point the global accelerator will direct us to the other endpoint. So we can now see that we have an unhealthy endpoint, and if we just head into the listener and go into US West 1, and we can see that US West 1 is definitely unhealthy. So let's go back and refresh our page, and now we go to the instance in US West 2. So that's exactly what we're expecting in the lab. We've basically gone from this point where we had one healthy instance, and that healthy instance then became unhealthy, and using the same IP addresses, we then were redirected to the second instance. So that's the way Global Accelerator works. Just remember, this is really good when you want two static IP addresses. So either the question in the exam might say something like, you need to be able to whitelist two IP addresses only, and you want to be able to fail over between endpoints in different regions. That's where Global Accelerator is really good. Another way it's really great is that it directs traffic over the AWS global network. So wherever you hear about having multiple endpoints and you need to reduce the latency between them, then because it's using edge locations and the global network, then it's actually lowering the latency for that traffic to your endpoints in different regions. So those are the kind of things that might come up in the exam. Now let's just head back one more time to the console, because all we need to do now is just go back in and delete our accelerator. So let's go back up to accelerators, and I'm going to choose the accelerator and delete. And you have to click on disable, and then that takes a few seconds. While that's happening, I've got to go and terminate my second instance. So just don't forget to clean this all up. That's done. Route 53, it's just a matter of deleting the record. You're not going to pay for that anyway. And then once the accelerator is disabled, you can go back in and choose delete. So I hope you enjoyed that. The AWS Global Accelerator is something that's definitely going to be showing up on the SAA C02 version of the exam. So make sure that you're fully aware of what it is and how it works before you sit the exam.